Hello, everyone, and thank you for joining me in this webinar. Today, I'm going to be talking about RavenDB and sharding. And this is a really exciting topic because we have been thinking and working about meditating and everything around the topic of distributed systems in RavenDB from day one. And sharding is one of those topics that keep coming up and being really interesting challenge to solve properly. But before I get into that, I want to give you some context about what we are talking about. First of all, what is sharding? And sharding is the process in which we take a large data set and partition that into multiple servers, where each shard contains some of the data. So far, this is about the same thing as having an encyclopedia with tells from A to C in one volume and D to F in another volume. This gets interesting because proper sharding gives you the illusion that there is a single source for the entire dataset. So able to ask questions across the whole thing, and everything just happens easily and quickly. We actually had, where is that? Okay, so let's talk about sharding just a little bit in the context of RavenDB. First of all, RavenDB currently doesn't have sharding, which is actually surprising because we used to have that, but we touched that in a little bit. When we're talking about large data sets, a few years ago by this point, time flies, we actually published a white paper that talks about how RavenDB handles terabyte range datasets. And even with a single node, RavenDB was able to handily beat competition that run on multi-node sharded systems. The typical distribution model for RavenDB is replication, and you would usually have three servers fully replicated to one another. So the data is replicated. If you need to have scaling, if you need to have better scaling, you can do load balancing across the nodes. But all of the data resides on all of the nodes. That actually means that we have a really simple system for most things. There is a problem. The problem is that all of the data must fit into a single node because you have to replicate it multiple times. And that can be an issue if you have really large data sets. What is large? If you can't buy a disk for that, basically. Just to give you some context, we tested RavenDB on billions of documents and terabyte range datasets running on a Raspberry Pi, which is utterly ridiculous. It has 4 GB of RAM and it's processing 1 TB of data, just to give you some context. But at some point, it's impractical to fit everything into a single server or single disk, and you need to move to multiple disks. Right now, we set that limit in the multi-terabyte range, 5, 10 terabytes. This is the stage in which I'm going to tell you, hey, you need to re-architecting. You can't put everything on a single replicated cluster. So let's talk about sharding in history. So the moment that you start moving beyond the multi-terabyte range, you want to split the data. Basically, this is where sharding comes into play. And this is interesting because RavenDB actually had that feature since 2012, 2013. So basically 10 years ago, we had this feature already available. But in 4.0, we effectively removed that. It was still available. You can still work with it as normally, but we didn't want to support that explicitly. And the reason for that is that the entire sharding implementation was completely client-side. So the client was responsible to go into all of the relevant shards, pretending that they are one single concept, etc. And one of the things that we focused on in RavenDB 4.0 and onward is the idea of having a seamless, unified experience. I do not want to have things that require a lot of client-side setup, a lot of complication, all sort of details that you need to do. That's not what we're here for. We're here to give you a database, you put the data, you get it out, and you move on and do other stuff. The whole idea is that RavenDB is boring. And we couldn't make it with a client-side implementation. So the whole idea with RavenDB 6.0 sharding is that we are now going to take ownership of the process. And a key aspect of that is that we want to be completely transparent for most things, to the point where you can point an old client to a RavenDB sharded server, and it's going to work. And this is pretty much how it works. Let me show you. This is a RavenDB 6.0 server. We're actually running this in a cluster. To make things interesting, you can see here, this is my machine. And this is a Windows instance. This is a Raspberry Pi. This is also a Raspberry Pi. So this is a really weird sharding setup, but we'll go there. So what I'm going to do now, I'm going to create a database called order. I'm going to tell it that we have a replication factor of 2, and I'm going to tell it that we have 3 shards to work with. With that in place, I'm going to hit create. This is an error that we'll touch on in just a little bit. And now we have a database. You will notice a lot of UI bugs. Feel free to ignore them. They're not actually there. They're artifacts of the way that we are revamping all of the details that we have in the studio. So now we have a database, and I can go here and say product/milk. And that's about it. I mean, absolutely nothing here should be surprising to you. If you pay very, very close attention, you will be able to see that we have something interesting here. Shard. That's new. But I can go here and issue a query. And I'm going to get the results. At least I hope that I'm going to get the results. Products. Apparently I cannot spell. Let's fix this and rerun the query. And now getting the results. And again, this is coming from shard 2. What is going on? So you can see here that I actually have multiple databases. Some of them are sharded, some of them are not. It doesn't matter for RavenDB. You can mix and match as you see fit. Let's see how this looks like. So for now, ignore the notion of orchestrators. Let's see what we have here. In this setup, I have a cluster that is composed of 3 nodes. This database has 3 shards with a replication factor of 2. For every node, every shard resides on 2 nodes in the system. And in this case, this resides here. So by the way, notice that shard 2 is actually on node C and B, which are the Raspberry Pis. I can use this to go directly to the relevant shard. Now you can see here you cannot see the shard. Why? Because we are now inside shard 2 directly. Let's go and create another one. Now I created some bread. And again, we have UI issues. And now this is located on shard number 1. If I'm going to see here, I have nothing here. Let's go and look at shard number 1. Just spread. So, and now I'm going to go here. Here is milk. And here we go. I can go and create a document called honey, and presumably this would sit on shard 0. Let's try that. Also shard number 1. So what did we have so far? We created a sharded database. We created some documents, and we saw just a little bit about how do we manage everything that is going on. Here's the goal. This is why we spend so much time on this. Everything works. Let me show you what I mean by that. You can see here, I have a Visual Studio. This is using the old 5.4 client. And what I'm going to do now, I'm going to connect to the orders one. And then I'm going to do this. I'm going to create a new customer. I'm going to create a new order, and I'm going to run it. And this is going to run. And connect, print it out. We're good. Oh, I should have moved this here. Never mind. Let's see what it did on the server side. Now, by the way, notice that here you can see where it is located. So here is order number 1 related to customer number 1. Everyone is happy. By the way, there is a Q&A option that is open. I would absolutely love it if you send questions this way. We have a first question from Adriana, and the question is, can you explain the difference between replicas and sharding? So it's actually very easy for me to do that. I can visually show you. What you see here is that we have a database, and this database is composed of 3 different shards, 0, 1, and 2. Each shard is actually going to reside on 2 separate servers. Look at shard number 1. I'm going to now connect to the Raspberry Pi. And we are going to look into what's going on here. There you go. So you can see it's running. Somewhere around here, it's colored, so it's harder to see, but here are all of the RavenDB processes. Good. And what I'm going to do, I'm going to stop the RavenDB server. Let's see. And now you can see node B is down. That sucks. Look at this here. Oh, see what happened. We'll ignore this. Node B is down. I'm going to go back here and ask my question. Let's even ignore the cache. I'm getting the result back. How does this work? Well, in the exact same way that you're used to. A node goes down is, okay, we have 2 of them for shard 1. If node B is down, I will go and talk to another one. If node B is down, we talk to another one for each one of the shards. So every one of the servers that we have is going, every one of the database that we have is going to be replicated. Notice that I still have not all of the data resides on all of the nodes, but I still have the ability to manage things easily and quickly. And in a few seconds, this one is going to go up. The server is going to monitor that, and now we're back in the usual manner. Everyone is happy. We have a question, another question from Alexandro. How do MapReduce indexes work in a sharded database? They do. I will talk about this in just a bit. Someone is asking, I might have missed this, but how do you define the sharding strategy per year or hashing the ID? The short answer is that we hash the ID, and you will see exactly in just a little bit. Daniel is asking, what's the logic? How does the server decide which shard to save each document? Generally speaking, based on the idea, we touched on that in detail in just a little bit. Okay, by the way, I'm absolutely loving the fact that you're asking questions. That makes it a whole lot more interesting to me. Okay, so here's what we have. You can shard the data, which means that you can increase your capacity. In the case of the Orders database, we have 2 copies for every piece of data spread across 3 servers. That's amazing. I don't need to worry much about this. All of the reason RavenDB exists is that you're supposed to just build your applications and not worry about how do I actually manage all of the minutiae. And we have been working on sharding, on this particular implementation of sharding. I think at this point, this has been 4 years. We had a team and a half, basically, that was just sitting there and working on making it work. And we are now at a position where every team finally clicked together, and I can actually show you how everything works. Adriana, every node is asking, every node contains a copy of all of the same data. No. Node A and node C contain a copy of shard 0. Node B and A contain copy of shard 1, and C and B contain copy of shard 2. In other words, if I'm looking at it from the perspective of node A, the node A holds the data for shard 0 and shard 1, but shard 2 is only on C and B. Russ is asking, is the transaction atomic across the shard host node, or does Raven use eventual consistency across the nodes? The answer is yes. I know it's not a good one. Give a moment, I have really exciting news here. The short answer is that you get to choose, and we have multiple levels that allows you to control exactly how this is going. Okay, let's see. First of all, this is the technology preview. This is by no means done. The 6.0 release is in the March-April timeframe, and we have focused all of the effort on making it work right. Now we're at the point that we have to make it work fast and pretty. So you will notice a lot of other issues with the user interface. For example, even the tag here is not shaded properly. Not much of other small details. Bear with me for that. We have a nightly build available that you will be able to take and start using immediately. Only use it for testing scenarios, and I would really appreciate your feedback on all of that. And with that said, I want you to understand how it actually works. What's happening behind the scenes? So let's look at this. If you look here, you can see that I have a whole bunch of databases. And here we have databases for Stack Overflow. Right now, I have a background process that is writing to the Stack Overflow database. The Stack Overflow database in this case is composed of 3 shards. Each one of them sits on its own node. So again, I have the ability to figure out how I want to do it in any which way that I want to manage. Now, going back here, you will notice that I have these interesting details here. What are those? Well, this is shard 0 of Stack Overflow located on node A. Shard 1 of node of Stack Overflow on B and C. By the way, we call it Stack Overflow here because this is actually the Stack Overflow dataset. If I'm going to look at orders is more interesting because you can see that shard 0 is located on A and C, shard 1 on A and B, shard 2 on B and C. So the whole idea basically is actually quite simple. A shard is a RavenDB database, the one that you've been using and familiar with. And it has all of the usual capabilities of a RavenDB database. What does it mean? It means that it has replication. You saw that it has high availability. You saw if you want to have encryption, you can have that and everything as such. Now, let's see some other fun parts. I'm going to use the orders, and you can see that, you know what, I don't feel like this is that interesting. Let's kill it from node C. But shard 1, that makes sense for me for some reason to want to run it on all nodes. So notice what I've just done. I removed the node from shard 0. Shard 1 is now having all 3 nodes. I have the ability to manage the number of replicas for each individual shard cheaply and easily. I can't think of a reason why you want to have this unbalanced, but you have the ability to do that. Now, you will notice something else. I currently have 3 shards, and we have a question from Brian that is asking, is the data rebalanced when a new node is added, or is shard size fixed at time of creation? Well, let's see. We have an option here to say add a new shard. I will touch exactly how it works in just a little bit. By the way, if you haven't noticed, I'm feeling really amazing right now. This has been the culmination of a huge amount of work. We had a large number of people working on that for a very long time, and the amount of detailed work that's happened behind the scenes to make sure that everything is happening properly is amazing. And we're finally at the stage that I can show it off, and it feels absolutely great. So how does it actually work? As a client, I have no idea this is sharded. This client comes before sharding even existed. I can actually go and change this to be a for client. This would also work. And I think that's a kind of amazing thing to have. But what actually happens, and we can see it very clearly, is that we have orchestrators. And let's talk about what are those orchestrators. An orchestrator is the piece of code inside of RavenDB that is responsible for accepting queries and operations from the client, send them to the individual shards, aggregate, process them, and then return the results to the client. This is the piece of code that is responsible for pretending that it is a single whole database. When I'm running a query, such as this one, the data comes from multiple servers. And it is responsibility of the orchestrator to see that. I'm actually going to show you how it looks like. Let's open node A. And what I'm going to do now, I'm going to look only on queries. In node B, let's look only on queries. And node C, only on queries. And with that in place, let's run the query. And now you can see something really interesting. Here is the query that I'm running. And you can see that it was running on shard 0. And it was running here on shard 1 and shard 2. So what happened was that I sent a query to here. And the orchestrator then decided where it's going to go. It got the results back and sent me the reply that I need. It's actually pretty smart and can do quite a lot for us. Here's how it looks like. Something that is really interesting, notice that we have non-overlapping topologies. We can actually have a node that is dedicated just to do sharding. And like any topology inside of RavenDB, you get to control this. You get to say things like, hey, you know what? I want you to usually talk to node C. And again, I'm sorry for the way that this looks like. We're working on the user interface. And now when we generate a query from the client, we're going to use node C by default. If node C is down, node A and then node B, just in the same way that we have the usual mechanism for working with regular RavenDB databases. You can use round robin, context-based balancing, everything. It just works. Now, let's talk about how we actually put a document in a shard. And first of all, we have to understand that this is actually quite interesting because I don't have just shards. I also have, let's see. Do I have, I can also have, let's find something interesting. Here is a big, where does this go? This is an attachment. It's sitting somewhere. And the answer here is that everything that belongs to a document always sits in the same location as the document itself. But how do we decide what that location is? So the unit of sharding is always the document. And an attachment, revision, all of those sort of things always belong to a single document. But how do we make that determination? The answer is that we do that using the document ID. And the manner in which we are doing that is using the hash function. So what we're basically saying is, okay, let's take the case-insensitive hash of the document ID, spread it around across 1 million buckets, and this is the buckets that we get. What's the point for that? Well, the idea goes like this. Hash ABC gives me, so this is the bucket for this. And here is the bucket for this, etc. That's about it. Some interesting things about this. This is static configuration. This is not even configuration. This is hard-coded into RavenDB. There's 1 million buckets in the system. And based on the document ID, you're allocated into a bucket. The hashing function that we use is XXHash. And the primary mechanism that we use for this is to say the following. Hey, you know what? I need this to be evenly spread across all of the buckets. And that's important because it means that as a user of sharding, I don't need to worry about exactly how it's going to work. I already have uniform distribution. Now, let's dig a little bit deeper. We have 1 million buckets, but we don't have 1 million shards. So the idea here is that we have shards, and as a reminder, here are the different shards, and each one of them is assigned a set of buckets. You can see that assignment here from 0 to 350 to 350 to 700, etc. So everything between 0 to 349,525 belongs to shard 0. Everything from here to here belongs to shard 1, etc. The idea here is the assignment of a document to a bucket is static, but the assignment of a bucket to a shard is dynamic. And I can change that as I see fit. We touch on that in just more in just a little bit. For now, let's see how it works in even more detail. So documents are placed in two buckets in a random fashion. In fact, let's go here and run it again. This is going to generate another couple of documents, 2 and 2. Let's see what they're sitting. Order number 2 belongs to 2, shard 2. Sorry. Order number 2 belongs to shard 0, or customer number 2 belongs to shard 1. So they're basically in different locations. I mean, I guess it's okay, but what happens if I want them to be in the same location? Well, and why would I want to do that anyway? I might want to do that if I want to have a transaction for the customer and its order. I might want to do that if I want to load the document. There's a whole bunch of reasons. In general, locality of reference is a really good idea. I want to exploit that. So remember that we have this thing. I can hash. So I can, and I'm using a non-cryptographic hash, so I can figure out how to create a hash collision. That would be complicated, and I don't feel like doing a lot of math. Instead, the way that we're doing that is a lot more simple. These two documents belong to different buckets. This document always going to be in the same sub bucket as this. Why is that? Because we hash from the last $sign. That's it. If you have a $sign, then we're good. Let's see how this works. I'm going to go here and now this belongs to node number 1, to shard number 1. Why is that? Because it has the same item that we hash in order to figure it out. So these are always on the same location. Edward is asking, can we use the purpose of sharding to keep some document only in a specific region to protect ourselves from several laws? This is called data sovereignty. The answer is yes. I'm going to touch on that. And so this is basically it. And now you have data locality. And because I love showing you how simple it is, I'm going to do this. So I wrote this code. And I'm going to run the same code that we have here. Let's see what it's going to generate. Here is customer number 3, and here is customer number 3. Because of the way we shard the document like this, we are guaranteed that both of these documents, customer number 3 and orders of customer number 3, are always going to be in the same shard. In fact, this is a stronger guarantee. They are always going to be in the same bucket. So even if we move the bucket around, they're always going to be the same. Now, let's talk a little bit about what it means to have a bucket. A bucket is the lowest level of data aggregation in sharding. It contains all of the data, all of the associate, all of the documents, all of the data, etc. And we have 1 million buckets. And think about what this means. If we have a terabyte dataset and uniform distribution of the data, one bucket is 1 megabyte. Even if I have a petabyte dataset, then one bucket is 1 gigabyte. We intentionally chose this value so we have lots of very small buckets, because it means that if I need to do something to the system, moving buckets around, rearrange stuff, those sort of things, I get to do that easily and cheaply. Shards are now containers of buckets, and I can move them around as I see fit. Now, let's see how this looks like. Let's see how we actually put buckets in shards. So you might be familiar with the storage report. Now we have a buckets report. And now you see something really interesting. We have an obese bucket. And we can see that because this single bucket takes 99% of my entire database. Let's drill down. But notice what we have here. This is 32,000 buckets. And now we are dropping down even further and further, all the way until we get to the individual bucket. And now we can see why we have this. So now I drop down to one location. Now I can see that it's because I have these disjointed values, it's very clear what's going on. Let's go and drill deeper into another one. Let's go into this one. And let's make it big as well. That would give us, now you can see slightly better setup for this. We have 2 obese buckets compared to everything else. And you know what? This is very worrisome for me. I need to split the system. So I created another shard. And now we have this shard. It resides on node B for whatever reason. And now what I'm going to do, I'm going to move that because both of these obese buckets are on shard 1. So I'm going to drill down all the way to the bottom, move this guy to shard number 3. And this is going to take a while, again, Raspberry Pis, etc., but it's working. While this is, okay, we are done. And now I would be able to go here and here. And here it is. You can see that the big bucket moved down, etc. Someone is asking, how do you determine with a query which shards have to be used? I would like to shard across the globe to reach and execute a query. Could the coordinator figure out it doesn't need to talk to the 2 other regions if there is no data for it in the query? And the answer for that is yes, you're able to do that. You have to tell RavenDB how to do that. I will show that in just a little bit. Dan is asking, what happens if a document is written, updated when a bucket is in the process of being moved? There are two scenarios here. First of all, notice that the idea here that buckets are small. In this case, I explicitly created very big buckets with attachments. And practically speaking, assuming that we're talking about real data sets, we're going to see far better distribution of data. For example, here I have the Stack Overflow data dump. You can see here some questions, here are some users. This is not a Stack Overflow data dump, this is a super user data dump. So this is slightly more realistic data sets than the orders that I'm showing. And you can see that because we are doing a uniform distribution, the amount of data that we have is almost identical. So, and let's drop down to look at individual bucket. And you can see this is just utterly ridiculous. 15 kilobyte, 10 kilobytes, something like that. It doesn't really matter that much. But what does it matter? What happens when this happens anyway? First of all, you might have noticed that there was notice here about moving, all sorts of states that happen. There is a handoff procedure that runs while we are doing a migration. You're okay to do writes when this is happening, and RavenDB will basically handle that. It would keep the migration process open until the entire data set has been properly replicated. And then it would do the switch over to say, okay, we used to be the owner of this used to be shard 0, now it's shard 1, etc. That's how it works. Okay, so we looked into how the shards actually look like. And we looked into an obese shard. But let's talk about what it means in the real world. So here's how it works. We have a big customer, and this big customer composed of 20% of all of my data, and I'm using this format for the document ID generation. This forces RavenDB to put all of them inside the same bucket. A bucket resides on a shard. This is a classic modeling issue. And if you use Cosmos DB, DynamoDB, those sort of things, this is a huge problem for them because you can break a bucket. And I chose this image purposefully because this is actually fine. Think about this. Here is the bucket distribution in the cluster. We have many, many shards, and all of them have roughly the same amount of data. They have different amount of buckets. So in this case, each one of these shards would have about 250 gigabytes of data. And shard number 6 would also have 250 gigabytes of data, but would have just 1,000 buckets in it, and not the 200,000 that you would typically have. And it's interesting because there are parallel ways of thinking about that, because we have buckets and shards, and documents are actually located in buckets. But this is just meant for organizational perspective. If I'm going to drop down and look at how the data is actually residing on disk, and now I'm looking at the individual shard, you can see this is standard data that I'm looking at. So even though we have the notion of buckets, an obese buckets isn't going to have an impact unless you have a bucket that cannot be stored in a single node. But a RavenDB database can store terabytes of data. So until you get to a bucket that is that big, you just keep on going and smile at the world because everything is going to happen just fine. Now, let's talk about transactions. RavenDB is a transactional database, always. This has been the first thing that we did in 2009, and it is still the case right now. Let's talk about this in here. What is happening? We are storing a customer, we are storing an order. And then we call it changes. And this is guaranteed to be transactional. Why is that? Well, because of this. I register the conversion. I will show you how it actually looks like in just a little bit. And I ensure that customer and order always reside in the same bucket. So it's always going to work. And now I want to show you how this looks like. Remember, we are now at 5.4. There is no awareness of sharding, but I can register a document ID generator, and I can say, hey, orders always belong to the same customer that generated them. And that means that in here, I can rely on this being transactional, because a bucket always sits in a shard, and a shard is just a RavenDB database, and RavenDB is a transactional system. If you have a cross-bucket transaction, then we have an interesting conundrum. If those two buckets sit on the same shard, they're going to be transactional. But I don't like that because they may move. So it's transactional on Wednesday, but it's not transactional on Sunday. That's not a good way to design the system. And on multiple shards, it's entirely non-transactional. I mean, it's transactional for each individual shard. But that's not a good definition of a transaction. You want both of them to fail or none of them to fail. We decided to allow this and make a note that this is a cross-shard operation, is not transaction. We have an option to fail such operation explicitly. So I can say, hey, globally, I want any cross-shard transactions to fail immediately, because we can tell from here right now that we're going to hit multiple shards because we use the documented IDs, and that's going to fail. However, RavenDB has cluster-wide transactions. Session options. Come on. And now I'm going to disable this. And what's going to happen is that I'm going to have two different documents. I would expect them to be on two different shards. And here is, okay, they happen to be on the same one. Let's try it again. Here we go. 2 and 1. And because I use a cluster-wide transaction, this is working. We have cross-shard transaction. And the only thing that it cost me is figuring out how to spell session options properly. Now, we actually have done that already, right? We added a new shard, we migrated data, we did it here in the buckets because we added shard number 3. A few things to understand here. Sharding, resharding, adding new shards, removing shards, all of those are things that are available. Currently, there is no automatic resharding process. Why is that? Experience has taught us that resharding is something that can be incredibly expensive. Why are you using sharding in the first place? Probably because you have lots of data. If you have lots of data, try to imagine that this number is in the gigabytes, and we're talking about 2.4 terabyte of data. Well, at this point, moving this to another server means moving tens or hundreds of gigabytes around. I do not want that to happen willy-nilly because of a server went down or something like that, and I need to consider what's going on here. So this is a manual operation only. We want to have feed experience on whatever we even want or need to have automatic processes. It is an intentionally rate-limited process. So we are going to be sending bucket migration slowly, which sounds crazy when you think about it. Why would I want to do things slowly? Well, the whole idea is that you take things slowly, one step at a time, and because the whole process is meant to be an online experience. Try to imagine that you need to reshard, you're under load, you're hitting capacity. The absolute last thing that you want to do is to say, oh, let's reshuffle all of the data and add even more capacity issues into the system. So the whole idea is that I can run live, online, and operate with no issues. Now, we had a question before about data placements. And there are many cases where you have to deal with data sovereignty. The easiest example is GDPR. I'm assuming most developers are already familiar with the headache that this entails. And I want to be able to say European data has to, or data about European citizens has to reside in the EU. Or you know what? I have a US-based cluster, but I don't want any data from someone in Florida to be in California because of whatever. That also the actual policy is something that I let the legal team struggle over. From my perspective, we just need to make it work. Now, I have a problem here. I don't have a user interface to show it to you yet. So I'm just going to point you where this is possible. The whole idea with sharding is that we have this option. And what does this option say? This says, give me the prefixes. And on those prefixes, you're going to tell me where all of the documents who has this prefix, you are able to say this is on node EUA, EUB, EUC. And everything from Canada with this prefix on Canada A, Canada B, Canada C, etc. And the idea here is data sovereignty is such an important concept that you have to encode it explicitly. So the whole idea is that document locality and document placement is both controlled using the document ID. For locality, we have $postfix. For placement, we have some prefix that you have. Omri is asking, can I get this recording? And the answer is yes, this is recorded. We will publish that within a day or two after we are done. Danielle is asking about compare exchange items. Do they also go on the shards? And that's a great question. And the answer is no. And let me explain why not. Here we go. So here you can see something really interesting. What are those? Well, those are compare exchange values, and they are used to record the association of a current cluster-wide transactional state of a document. The basic idea in the end is that those are shard cluster-wide, however I want to define that, values. So compare exchange are not sharded. In general, I can't think of a reason why you would want to have those sharded, mostly because they are already existing on all of the nodes in the cluster. John is asking, can you discuss calculated complex indices that reduce multiple related documents that have a high write load together? Will documents in the index result live on the same shards together? The short answer is yes, we discussed that. Yes, they live together, and this is actually really, really awesome. I will show it to you in just a bit. So after talking about those all of those high-level details, I want to drop down. I want to talk about how do we manage a single request, a load of one document, with a caveat. we load the document and we want to get all of its groups. So we have send a request to the orchestrator. The orchestrator computes the bucket for this user, for this user's document, and then based on this bucket decides where it's located. From this, it sends the request, it forwards the request to shard number 1, and we get some results back. Notice that groups users belong to a different bucket. It is not on shard number 1. Orchestrator notices that. It says, oh, I have group users. It goes to shard number 0. So it go and get that separately. From the client perspective, you get everything in one shot. Now, what I want to do, okay, let's kill this. What I want to do now, I want to now look at document loads. And then we're able to see exactly how this works. So what I'm going to do now, I'm going to go and look at where we have orders 26. So here is customer, here is the order, here is the related customer. Clear, clear, clear. Now we can see something really interesting. It happened that both of those requests were sent to node C. Notice that they went to different shards. So first we're asking to get this thing, and then we'll get it this one. In general, you can think about it as a very simple mechanism. The orchestrator accepts the query, in this case, the load request, and decides how to handle that. And it decides how to handle that in the most obvious way that you can imagine. Now, let's look at queries. Queries are really interesting because of how they have to work. So let's look into this. I have a query, and let's go to orders. We have a nice query here. How does this work? Let's see that in detail. Sorry. And now let's see what happened when I'm running the query. So I send the query to orders, and the orchestrator send the query to orders number 0, to order 3, to the 2 and 1. He then stitched together all of the operations and gave me the results back. Now, everything works. I could now do things like order by. And everything works, and even though it's coming from different servers, the orchestrator is able to handle that. Something that you have to be aware of, deep paging means that if you're saying, give me first page, that's easy. If you tell me, give me the second page, we have to get 2 pages worth from all of the nodes in order to handle that. If you're saying, give me the 1000 page, we have to get thousands of pages from all of the nodes, sort them, and then get them back. So be aware of the page. What about what happens when we are running MapReduce operations? For example, we have orders, and I want to say to ask how many times. Let's do this. Let's create This is for customers too. Okay, that's good. Form orders, go by customer, select customer, count. And this is going, it's going to do some work. And now we can see something really interesting. We have 2 results for customer number 2. Where do those reside? Let's go and see what happens. So 1 second. For models, where customer equal customer slash C. So order number 2 is on shard 0. This one is on shard 1. When I execute this, what does the query does? Well, it sends a request to all of the servers and re-aggregate the results. We have certain views that do not make sense anymore in the context of sharding. So you get to choose which shard and which node to look at. So in this case, you can see here is the result. Map with this visualization. Here is the result for customer number 2C, which is 1. And now I'm going to switch to shard number 1. Here is it again. And now I can reshard this. Sorry, now I can re-aggregate this. Now, this is interesting because this is a pretty simple scenario, right? Let's see what happens when we do something more interesting. And now we have indexes that I created. Full text search, question tags, something like that. Now I'm going to query. Tag should be good. And again. So apparently this is a database, database question. FileMaker. I haven't even heard about FileMaker in a very long time. And then we have this, etc. So this is from node 0, 0. All of them are from node 0. Let's find another one. Okay. Not my lucky day to get everything from node 0, from shard 0, sorry. Let's try something else. Yeah, I know what the problem is. Sorry. I was sorting on the wrong field, so it didn't count that, so it gave me in the order that it felt like it. 1 second. Okay, apparently I'm silly. I had a typo here. So let's fix that and see what happens. So now we have to deploy the index to all of the servers and all of the cluster nodes. And we can even go and look at all details. Please remember, this is still early days for the user interface. You would be able to see exactly how things are happening in each one of those. Notice that this is a side-by-side index that is deployed usually. Here is one where I actually got the values correct. So let's search for it here. We'll search about me, let's say London. And now we are doing a full text search with sorting, and here is, apparently he's a very good astrologist, whatever. And we have the results. But also, this is still simple. Let's talk about what happens if I have a more complex something. What happens if I have a MapReduce index? Well, here's a MapReduce index. I'm sending all of the results to the other side, where rank equal gold, order by month Look at this. This is doing cross shard reducing. And to answer the question that John had slightly earlier, this is actually also applicable for more complex scenarios. And the way that it works is quite simple. We are doing the indexing at the shard level. So what happens, and you should be able to see it here. Here we go. Oh, suppose okay, you should. I don't know why it's not showing me that. Never mind that. What happened? We are in the super user scenario, and in the super user scenario, what do we have? We have the data that resides on these individual servers, these individual shards. And what happens then is that we push the indexes to them. So all of the indexing is happening locally. And at query time, we send the queries to all of the shards, get them back, and then see all of them together. If necessary, we do reordering, paging, reaggregation, stuff like that. This also applies for things like fast search, suggestions, all of the sort of things that you might expect. And the whole idea is that, again, we are back at seamless scenario. Now, we have a problem here. The more data I have, the actually more expensive I am because my queries are all scattergather. But I just spent a whole bunch of time looking into this. Where is that? Look into this. If all of my data looks like this, how does this work? Here is my order ID. I want to query for this customer. Let's see how this looks like. And again, we're now looking at just queries. For models, it would help if I use the wrong. Here we go. So as you recall, order 0, order 3, order 2, etc. But now getting 2 results. Why? Because I also have this. I can also do this. And now you notice something very interesting. We are now telling RavenDB, I want you to direct this query to the shard that contains this bucket. So instead of sending that to all of the shards, just go to one location. And if your documents are following this process, by specifying this, everything just works, and you're now doing a point query instead of a scatter gather. Given typical data modeling, it means that you have this huge benefit here. Now, obviously, this is something that you want to expose to the client as well. So let's look at this. Here is my query. And with this, let's see what happens. I'm going to run this, customer 197. Let's see what happened. See what happened here. For models customer, and the shard context is for customer number 2. Sorry, this is not it. Where is it? Okay, here it is. So that's the one. Customer 197. And this only hit the relevant data, which I think is this one. No. Let's try it again. Clear everything. To make it easier for me to see where it's going. So this is running. And just send that to the void. I don't know why it's doing that. If I drop this, oh, I have, I don't have the right data for this, obviously, and etc. Okay. Anyway, so the whole idea is that you're able to do this, and again, all client, and now you're saying this. I want to add this context for the query. And someone is asking, how does optimization take into account includes? And the answer is that include is processed afterward. And if, let's go back to this one. So include a customer. So obviously this would include this because this is the same location. But now, I'm just trying to figure out something that would tell me where it's at. Okay. So notice that now I'm using the wrong shard context. I'm getting this from the wrong location, from shard 1. I'm still able to get this. This comes from whatever shard this is supposed to. Again. So I have to disable the caching here. And I'm messing something up with the behavior. I don't think that we are seeing what we're supposed to. Okay, this is customer C. There is a problem with Studio with the way it presents the information. I'm not going to, but you can see that it gets this and it's get this. So the way that it works for includes is even if you have this, remember that this the shard context applied here, where we decide which shard to send it. Then we send it for the first time, and then here we decide on the includes, and then we go again if we need to. Okay. So we also have support for subscriptions because subscriptions are awesome. And I mentioned that, let's do that on super user, that's more interesting. From users, well, downvotes equals 0. And this from 0, this not, etc. This is going to be more interesting. Now we have to scan a lot more details because most of the users apparently don't have downvotes in the super user dataset. But in a short order, this is from shard 0, shard 1, etc. The interesting about this is that subscription works as you're used to, even if you're working on cross-shard stuff, and you can get a batch that has details from multiple shards at the same time. When you complete a batch, that's transactional. You completed the batch entirely. If you fail in the middle, if a node failed, the server side or something like that, you have all of the usual reliability scenarios that you have. Now, let's talk about ETL and other things that you can do. Aside from tasks, you can, by the way, I want to show you, because this is funny. Just the user interface of trying to model all of this together. We haven't had a chance to deploy that, so it shows in red, etc. You also have notice that replication hub and sync are not supported for sharded database. I will talk about this a little bit later. Everything else here is supported aside from that. And in particular, let's talk about what happens if we have ETL of some kind. And all of the ETL processes are supported. Well, the way that it works, we push those tasks down to the individual shards, and they know how to handle this properly. And they send all of the results to the other side. You have to be aware that individual shards are going to execute those tasks in parallel. So if you have 3 shards and an ETL task, you're going to have 3 times the load. Another thing that is important, this is happening at the shard level. If you have a bucket migration, then both the old shard and the new shard is going to have to execute the ETL process. The way the ETL works in RavenDB means that they would converge and get to the right result. That's something to be aware of. For Kafka and RabbitMQ ETLs, we have to use the idempotency option to make sure that we don't resend the messages over the wire. That's another reason why we want to have bucket migration as a manual step. So you as the administrator has full control over that. What about replication? Basically, it's working for any level of craziness that you want, including, by the way, you can replicate from a 6.0 sharded to a 5.4, which is obviously not sharded. And the way that it works is between sharded and non-sharded, even between different number of shards. So it's a whole big part in everything works. Someone is asking, in 6.0 shard without sharding, we'll use just one shard and hide it in the UI? No. There is still an important distinction. If you're running a sharded database with one shard, this is still sharded. And this means that there is an orchestrator involved and everything else. If you're using a single database, a normal database, then there is no orchestrator in the middle. Espen is asking, is it possible to shard documents by create date and then the shard January? No. January 23 to February 23, etc. No. And the reason why not is that because that's going to lead to really complicated setup. Technically speaking, what you can do, you can say, hey, I'm going to define those prefixes. What was that? I'm going to define prefixes like that and control where they would sit. So that is possible. I would really hate to see that. That's not the scenario that you have. You have to be aware there is an upcoming support for a feature we call data archiving, which is going to help you work with moving all data into colder storage and all that is associated with it. But this is unrelated to Sharding, and hopefully it's not going to be relevant for the feature. Okay. More questions first of all. So with regards to ETL, we have Danielle who is asking, can you ETL just a single shard content, backup just a single shard? So no, sort of. ETL is defined at the database, at the sharded database level, so it applies to all of the shards. If you really, really, really wanted to, I can give you an option to say, okay, if this is from the wrong shard, skip it. I can't think of a reason why you want to do that, and that sounds like a really scary thing to do. About backup of a single shard, let's talk about how it's done. So backups are, again, defined at the global level and then drop down into the individual locations, individual shards. You can define a backup destination on the local node, in which case each shard is going to be backing up to the local machine, its own local machine, or into some shared resource such as S3, blob storage, etc. With all of the usual features such as encryption, scheduling, etc. We do not support for sharded databases. We do not support what is backups? We do not support snapshots. So that's something to be aware of. We are supporting the backup feature. Why is that? The way that we work, of course, when we start a backup process, each shard is going to run its own backup procedure. Let me see if I can show it very easily. Blah, 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 local. And orders. Okay. Now let's save this. It's going to do nothing, and I don't have the visualization for that any longer. That sucks. So the problem is that we have so many moving items at this point that it's hard to show. But here's how it works. Shard 0 is going to run it at node A. Shard 1 is going to run it at one of these nodes. Shard 2 on one of these nodes, and shard 3 on node B. All of them are going to be running on their own schedule, but it's not transaction across all of them. So it's not a globally consistent point in time. With the restore, you have the ability to take all of the individual shards and restore them together into a sharded configuration or a non-sharded configuration. For a single shard backup, you can restore that individually. Important to understand if it's okay to restore a sharded backup into a non-sharded database and a non-sharded backup into a sharded database. But a sharded backup to a sharded database must use the same configuration. What is the same configuration? The same number of shards. Okay, let's talk about high availability. We actually have already seen that. This is this demo when I stop node B. When this happens, notice what's going to happen at this point. In a few seconds, this is going to go red. Now, in this scenario, we're going to be in a bad state because node B has no alternatives. So if I'm going to run a query now, we're going to hit node B, we're going to be very sad. Notice that you can also define this. In this case, we say allow dynamic database distribution. For shard 2, we want to have 2 copies of the data. If this is going to be if this is going to be done for a significant amount of time, typically 15 or 30 minutes by default, then the cluster is going to automatically add node A to shard 0 to make sure that we have a sufficient number of copies. Orchestrator, by the way, also would failover normally and everything just works. I'm going to start it in a few seconds. This is going to go back up. If there have been updates to the database to the shard while the node was down, then we're going to accept them and move them on. And the usual, basically, the way that it always works, and not something that you really have to think about or work in many cases. The primary goal that we have for sharding in RavenDB is that we want to give you more tools and have better capabilities. You saw me within the span of an hour and a half or so, we created sharded system, put some load into them, added shard, remove shards, move them around, failover, all of those sort of things. And the entire process is all and available and easy. This is the highlight from my perspective. You throw data into that, it's just going to keep on chugging. Let's talk about how you can migrate to sharding. There are two typical ways that you do that. You have an existing database, and what you're going to say is, hey, I want to import, export the data, import that, one-time operation, just going to work. And the way that you do that is something like this. No, let's do that live. World building. So I create a sharded database. Again, this is an annoying bug in the studio. Import data. Oh, come on. Good enough. So now I'm importing a dataset that I have of Reddit users. And you will be able to see it here. Here, all of the users. And we are writing that to 3 nodes. And it's running and processing whatever. That's one side of things. The other option, that we have is to define a replication from an existing database, external replication to the remote server, which is sharded in this case. This is the benefit that you can make it work for a long period of time. For example, we have this database. It's 40 million documents, and if I'm looking at the storage, this is significant amount of data. I think you will agree. Not huge, but significant. And we have here an external application. By the way, this is a single server. No, it's not sharded. And we are saying, I want you to replicate to the Stack Overflow database in this location. We can actually see that when we're pushing the data. This is happening while the system is alive and well and operating. You can let it run for however much time you want. Think about what it means. The design means that your existing data model works. You can shift your existing application to sharding by just tell it, here is a sharded database, go and run. Now, it's ideal if you also take the advantage of, oh, I have the ability to define the locality, I maybe want to use the prefix for better control or something like that, but the whole basic idea is that it's just going to work. And you don't really need to have an expensive migration step. This is also something that we thought about for when you start on new projects, because the whole idea is that you can write your code as if you're running on sharding, not pay any cost for that, so you don't have to go to the orchestrator proxies, etc., and run it for a while. Oh, you're wildly successful, you hit the terabyte benchmark and you want to start running on sharding, set up application, let it run, and you're pretty much done. An important aspect, sharding has a cost. If you're not expected to be in the multi-terabyte range, then you probably shouldn't bother with that. It doesn't make sense. For the Excel application migration, really know when it's done. I'm not aware of seeing the overall progress somewhere. For migration, you actually have progress. And let's go here and here and ongoing tasks. Oh, come on. Sorry, I mentioned that this is let's see if that will work. No. Okay, so if you will look in your copy of this and look here, there is typically some entry here about that. But the way that you can check that in the easiest way, details. Okay, you can see here that we have here A811 something something. If you go and look at the start overflow data set, you can see that this is where we are at. So we are about the 1/3 of the way done. And that's how you can see that. And basically, you can see also here, and this is, you basically just, you see that. You see the last document that they have in the source is also the last that they have in destination, or you compare the change vectors or something like that. Okay, a few caveats. We go through a huge amount of hassle to make sure that what you see looks like exactly like it's a standard RavenDB database. But sometimes distributed systems are distributed systems and you can't pretend without having too much cost. So pool applications is not available. It doesn't really make sense, at least so far, so we disable that. If you put a document in a patch script, you have to be aware that it has to belong to the right shard. Output map reduced to documents are really complicated because of you may have duplication across shards and how you handle that. Rolling on index deployments do not make sense in this context. If you call log document, both in indexes and inside a projection, it applies only to the current bucket, not to the current shard, to avoid creating data dependency that you're not aware of. There's a whole bunch of other minor things that are edge case on edge case for the most part, but for the most part, I have to say that we did a pretty good job in abstracting all of that away. Almost to the end, the whole idea here is that this is not meant to be something that you would be find super exciting, amazing. RavenDB continue to work in exactly the same way, but now you can go, poof, you're bigger. There is no need for state management. You don't need to worry about all of those details. Probably the most important thing that you have to take away from this, one of the things that we learn from experience and looking into pitfalls that other distributed sharded databases have run into, is that your early decisions are almost guaranteed to be wrong. So the design of RavenDB was, the design of RavenDB sharding was very explicitly meant to make it as simple as possible to grow, and you don't need to worry about a decision you made very early in the project causing a lot of headache down the line. I mentioned that we have nightly builds, so you can go right now and go here, and here is the nightly build. I'm throwing that in the chat if you want to see that as well. This is the 6.0 release. It has almost everything that we have as of this point. It is a technology preview. We still have a lot of stuff going on, and the studio, and you saw some of the issues that we have to run full benchmarks and a whole bunch of work, but I would love it if you have any more feedback. For documentation, we are still working on that. I have to tell you that I've run the sharding project for so much time. We put a lot of effort. The moment that we have something visible, we wanted to go and show it for everyone. I don't think that there's a lot about sharding that I haven't covered. If you have any questions, the GitHub discussions is the best place to ask for that. James is asking whatever we have Docker images for this. Not right now. I don't know if I want to make it, to be honest, I don't know if I want to make it too approachable for people to start playing with that at the previous stage. And that's about it. And with that, I would accept any questions except about why we chose this thing, this picture. And let's see, we have more questions. Ras is asking, that was my question. And I will answer that anyway. I asked Dali to give me why is Raven teaching Rhino about distributed computing in front of a whiteboard or something in this order, and this is what he came up with, and that was scary and fun anyway. As a reminder, you can go and try RavenDB in the cloud, and we have a live demo options. You can see those right here. The cloud is currently not showing the 6.0 edition. We only have 5.4 in the cloud at this point. We will have that once we go into the beta stage. As I mentioned, now we are in the technology preview. Dimitri is asking, when is RavenDB 6 is expected to be released? And the answer is that in the March-April timeframe. The current status of the 6.0 release is that feature set is done. We are now working on performance, the studio, and the polish, making sure that all of the little things that works properly and right. And with that, if you have any additional questions, we would love to talk to you. You can ping us here. Thank you very much and have a great day.